Hello, this is worksheet 5.1. We're going to be graphing parabolas. Yeehaw! Given the following equations, find A through C. So we need to know whether this function, this parabola, opens up or down, the axis of symmetry, and the vertex. Which really, I'm going to start with the, axis of symmetry, vertex. I was going to switch the order that I did those, but that doesn't matter. So anyway, it's going to open up if your leading coefficient, which is the value in front of the highest degree, which in this case, in these cases for this unit are going to be the x squared unit. If it's positive, it will open up. If it's negative, it will be going down. So because it's a positive 1, it's going to be opening up for this one. Whereas here, your leading coefficient, the coefficient of the highest degree term, is actually a negative 1. So this one's going to open down over here. All right, now let's get the axis of symmetry. The axis of symmetry is going to be a vertical line, which means the equation is going to be x equals some number. What is that number? It's going to be the opposite of b divided by 2a. And if you're asking, well, what the heck are a and b and c? I guess I didn't talk about c, did I? But what are a and b? A is the coefficient of the x squared term, b is the coefficient of the x term, and c, which will come up later in this unit, is the constant or the term without a variable attached to it. So b here is negative 4 because the minus sign affects the 4 to make it negative. So this means the opposite of b. So that'd be a positive 4. The coefficient here is 1, so that's 2 times 1. So really we have 4 divided by 2. So x equals 2 is my axis of symmetry. That's a vertical line through where x is 2. Then to find the vertex, well, we have the x coordinate, so to put it in function form here, f of x, I know that the x value is 2. So I want to know the value of the function when x is 2, so I'm substituting 2 in for x. We substitute this, 2 squared is 4, 4 minus 8 is negative 4, negative 4 plus 8 is positive 4. So I believe, so this equals 8. So when, or did I say it was 4? God darn it. It's going to be 4. So when x equals 2, I inputted 2 for x, y is 4. Let's try that over here. We already know it opens down. Axis of symmetry is going to be the opposite of b over 2a. Now this one's not in standard form, which is kind of mean. So b, I guess, still is the middle term here, and the opposite of negative 2 is positive 2. And then we'll have 2 times our a term, or our leading coefficient, is negative 1. So we get 2 over negative 2, which equals negative 1. So my axis of symmetry is a vertical line through negative 1. And then let's assess this function when x is negative 1. So substitute negative 1 into the function. Alrighty, so I'm going to do a little chop slash in here. So really we have 3 plus, and then negative 2 times negative 1 is 2, then minus, negative 1 squared is a positive 1, but we're subtracting that off. So I'm getting 4 here. And by the way, folks, you should probably use a calculator on this. Just good to double check. It's fine to do the mental math that I'm doing, but double check with the calculator. I could have just screwed that up. So see what your calculator says. Make sure you use parentheses when you substitute values in for x. So now we're going to actually graph the function. We're going to use those same 3 skills, A through C, that we just answered previously to do these. So like for number 3, I know that this, when you look at A through C above, the first question is, does it open up or down? Well, I know that this opens down. So when I graph this function, because the directions say graph the function in standard form, label the vertex and the axis of symmetry, when I graph it, I'm expecting to see a frowny face. And if I don't, I made a mistake. So let's do the axis of symmetry. So x equals the opposite of b over 2a. So that's going to be a positive 8 over 2 times negative 2. 2 times negative 2. So that's 8 divided by negative 4, which is negative 2. So the axis of symmetry, AOS, axis of symmetry, is x equals negative 2. And so then, to get the vertex, I need to evaluate the function when x is negative 2. So negative 2 times negative 2 squared. Notice I'm just substituting negative 2 into the original equation up top. And let's see here. We get 4 times negative 2 is negative 8. Plus 16 is positive 8. Plus 1 is 9. So right now, I think I hope the vertex occurs at negative 2 comma 9. So left 2, up 9, 2, 4, 6. Oh man. Yeah, sure enough, this 9 is right there. Usually it's 10 on the graphs that I've been using, but we're going to go with that. So then, folks, from here, I can envision, I'm just going to sketch it. It's going to be messy. I'm going to erase this in a second. I'm going to get a frowny face, an upside down parabola going through it. But I'm not sure exactly where it goes. So I'm going to find what is the actual height when x is negative 1, where I'm putting those crosshairs right now. I'm going to get one point to the right of the vertex, and then I can just transpose that across that axis of symmetry. If I get a point right here, I know the point to the left of the vertex is right there. So I'll get one to the right, which gives me one to the left, and then I'll calculate one more to the right, which will give me one more to the left of the last dot that I transposed or reflected. So let's get rid of that sketch, and let's keep moving one to the right. So one to the right would be evaluating the function when x is negative 1. So here we get 1 times negative 2, which is negative 2. Negative 2 plus 9 is 7. 7 plus 1 is 8. So that's negative 1, 8. And then my axis of symmetry is a vertical line through the red dot. So that gives me, if I reflect it about this vertical line, it goes right there. And then last but not least, let's go one more to the right. That'd be 0, which is a nice value to do calculations with, because these first two x's that I'm substituting 0 in for just become 0. This term is 0, this term is 0 once I do the squaring and multiplying. So I'm just getting 1. So 0, 1, and then I better put that axis of symmetry in. And you know what? I think I did a small calculation mistake on that last dot. We'll talk about that in a second. But let's get this 5th point. So then it takes 2, I'm 2 away from the line of reflection, or the axis of symmetry. So then I reflect it 2 on the opposite side. Right here in black, I think I made the mistake. I think I might have said it right, but wrote it wrong. So we get negative 2 plus 9 is 7. No, that's seeming good. I feel like this should be a 7 right here. No, it should be. Oh man, that's embarrassing. So this gives you positive, or negative 2 rather. This is positive 8. And then, so that makes 6. This is a 7. Boom, boom, boom. Ba-dum, ba-dum, ba-bum. How I knew that, folks, was from experience. And whatever this vertical change from the vertex to your next dot over, just this one right here, it's just starting it out. Whatever that coefficient of x is, which is negative 2, that'll be how many you drop from the vertex to the first point. If it was a negative 3, I would have dropped 3. If it was just negative 1, I would have just dropped 1 from the vertex to the next point. So with experience, I know that that's what happens, and that's how I actually caught that mistake. All right, let's try number 5. So the negative coefficient, negative leading coefficient, so it's going to open down. Axis of symmetry, x equals the opposite of b over 2a, so negative 6 over 2 times negative 1. So that's negative 6 divided by negative 2, which is positive 3. So let's figure out the actual vertex. So what is y when x is 3? So we have a negative parentheses 3 squared. That negative has to go outside of the parentheses. Plus 6 times 3 minus 6. So I had square 3, which is 9. Anytime you square anything, it's going to be a positive, because anything times itself is a positive. So I have positive 9, but then I take the opposite of that. So I really have a negative 9 right here. And I add 18 to that, which gives me positive 9. And then I minus 6, that gives me 3. So 3, 3. Maybe I should write the coordinate pairs, that'd be nice. So 3, 3. This is my vertex, and again, my axis of symmetry is a vertical line through that point. I better just use a... Come on, Bessie. Better use a straight line tool here. Oh, this will be over the top, but hey, why not? So there's my axis of symmetry. I'm going to move one to the right. You can go one to the right or one to the left. It doesn't matter, but I'd rather use a smaller number. So if I go one to the left, I'm using 2. If I go one to the right, I'm using 4. Because I make mistakes, and I'm doing this mentally right now, I am going to use a smaller number. So I'm going to go one to the left and then just reflect it over the axis of symmetry to get the point 1 to the right. Substituted things in. Here's 4, but it's actually psych, the opposite of 4, which is negative 4. So we have negative 4 sitting here. Plus 12 is 8. Minus 6 is 2. Remember when I talked about whatever the leading coefficient is? That's how much you rise, or in this case, drop from the vertex to the next point. Well, the leading vertex is negative 1. That's what I'm dropping. And then I reflected it over there. All right, let's go one more to the left, because I want to use a smaller number. So negative 1 squared, negative parentheses 1 squared, plus 6 times 1 minus 6. So 1 squared is 1. Make it a negative 1 with the negative outside now. Plus 6 is, well, actually, honestly, this is going to be 6 minus 6, which leaves me with that negative 1. So 1, negative 1. And then reflect that point across the axis of symmetry. And by the way, this was when x was 2, y was 2. There we go. All right, I think that's it for this section. Yeah, let's try graphing another set in another.